Welcome to another lesson in this our series where we are still treating the real number system. In today's lesson, we will be focusing on the highest common factor of two or more numbers. The highest common factor of two or more factors. So we have highest common. I mentioned this topic in the previous lesson. that we will be looking at it today. Therefore, whatever we learned in the previous lesson, we are going to build upon it. And I mean the prime factor tree. We are going to build upon the prime factor tree. So there are two names for this. We have the highest common factor or the greatest common divisor. Yes, so we have the greatest common divisor or the highest common factor. Now, with this, you'll be given a set of numbers. You'll be given a set of numbers, maybe two or more. So, for example, find the HCF of, so let's say of 6 and 9. So it could be more than 2. So maybe 6, 9, 12 or any other number. So here we are just looking at 6 and 9. We want to find the highest common factor of 6 and 9. Now the traditional way is that your first step is, now let me write the HCF in full again. Highest common factor. Highest common factor. So looking at this, it means first of all we have to list the factors of the two numbers. The factors of the given numbers, let me put it that way. But here we have 6 and 9. That means first we have to list the factors of the given numbers, and in our case is 6 and 9. Numbers. So in our case that is 6 and 9. Now looking at it again, we have common. So if I add common to the factor, now we are looking at the common factors from what we listed. So we write down the common factors. And when I say common factors, I mean numbers that you can find in both factors. When something is common, it means it can be found in one area and can be found also in another area. So when we list the factors of the given numbers, we are going to list that of 6 and 9. Now out of those factors we listed, we are going to look at the numbers that appears both for the 6 and for the 9. That is the second step. Then the last step is highest. So after listing those common factors, you pick the highest number from the common factors. Pick the highest number from the common factors. Right, I believe this is clear. So just by judging from the name highest common factor, we can solve it from this direction, from the right direction. So you list the factors. First of all, you list the factors. Then you combine the common to the factor. So we have common factors. Then you combine the highest to the remaining so that we have highest common factor. So the first step is let's list the factors of the given numbers. Now what are our given numbers? If I look at, we have 6 and 9. So let me keep the steps up here so that we refer to 6 and 9. Let's list the factors of 6. So factors of 6. And I believe by now you should be able to solve the factors of a given number easily without even having to go through the Hill method. Then again, I list the factors of 9, which are 1, 3, and 9. 1, 3, and 9. So I believe our first step is done by listing the factors of the given numbers. Now the second step, which says we should write down the common numbers. So the second step, we have the common factors. Common factors, which is, so out of these two, from these two factors, what numbers do we find here and also find here? What numbers do we see here and also see here? So we see 1 and 1. So then I can put 1 as part of my common factors. We see 2 here, but 2 can't be found here. So that is not common. We see 3 here. 3 can also be found here. So I can list 3 as part of my common factors. We see 6, but we don't see 6 here. It's not part of the common factors. And the last one, we see 9, but we don't see 9 here. So I believe I have only 1 and 3 to be my common factors. So after listing the factors of the given numbers, you pick out the common factors. I can then check off the second step. Then the last step is to find the highest number from those common factors. So I can now say highest common factor is equal to 3, because looking at 1 and 3, 3 is the largest, 3 is the highest. Out of those common factors, and these are the common factors, 1 and 3, the highest is what? Is 3. So therefore, the HCF, or the highest common factor, of 6 and 9 is 3. The highest common factor of 6 and 9 is 3. I believe this is clear. If there is any misunderstanding or confusion, please leave a comment in the comment section. Let's look at another example. So find the HCF or the GCD of 5, 10, and 12. 5, 10, and 12. So the first step, which begins with the F, is to list the factors. So factors of 5, we have, yes, you are right, 1 and 5, because 5 is a prime number. 5 is a prime number. Factors of 10, we guessed it right. We have 1, 2, 5. Then the factors of the last number, we have, that is 12, right? So we have 1, 2, 3, 4, and 6, 12. These are the factors of 12. And that is our first step, to list the factors of the given numbers. Now let's proceed to common factors. Let's proceed to common factors. So what number can we find over here, over here, over here, over here, over here? So I believe you have 1 running throughout. We have 5 here, we have 5 here, but unfortunately we don't have 5 here. So 5 is out. Then again we have 2 and 2, but 2 cannot be found here. So 2 is also out. The same for 3, 4, 6, and 12. So I believe the only common factor we have here is 1. We are left with only 1 as the common factor. Therefore, the highest common factor of 5, 10, and 12 is just 1. It's just 1. Unfortunately, we couldn't find any bigger number. We just had 1. Don't be scared. You are not wrong. 1 is the common factor among those numbers given. 5, 10, and 12. Right. Let me give you one to try. So I'll give you one to try. You pause the video, you try it, and we'll take the solution together. So find the HCF of 4, 16, and 18. 4, 16, and 18. So pause the video, write your steps in your notebook, and let's look at the solution together. So here is the solution. Now the question says we should find the HCF of 4, 16, and 18. The first thing to do is to list the factors of those given numbers. So we have our first number to be 4, and that is 1, 2, and 4. 1, 2, and 4 to be the factors of 4. And factors of 16, we have 1, 2, 4, 8, 16. Factors of 16, we have 1, 2, 4, 8, and 16. And factors of the last number, which is 18, we have 1, 2, 3, 6, 9, and 18. We have 1, 2, 3, 6, 9, and 18. The next step, as we all know, is to list the common factors. So common factors. So we have 1 running across, 1. We have 2 running across, we have 2. Unfortunately, we have 4 in 2, but not the third one. Yes, I don't see any common factors again. So that brings us to the end of the common factors. So now the highest common factor, therefore the HCF of 4, 16, and 18 is, out of this, what is the biggest number? You are right, it's 2. The HCF of 4, 16, and 18 is 2. I believe this is clear. Listing the factors of the given numbers, finding out the common factors, and picking out the biggest number from those common factors. These are the major steps in finding the highest common factor of given numbers. Now I will introduce you to another way of finding HCF. Finding the HCF Finding the HCF using the factor tree, the prime factor tree. That is why it is very essential to follow the series thoroughly and you don't skip any of the lessons. We've treated the prime factor tree in our previous lesson. So I would want to take a look at the examples we already did. So where we had, I can use the same numbers. Six and 9. Let's use 6 and 9. Yes, let's use 6 and 9. So we have a HCF of 6 and 9. There are some steps we have to follow. The first one is express the given numbers. Express the given numbers as a product of its prime. Express the given numbers as a product of its prime. And that is by the help of the factor tree. That could be achieved by using the prime factor tree. Then 2, you write down the common prime factors. Write down the common prime factors. So out of the prime factor tree, after expressing it as a product of its prime factors, we write down the common prime factors. Then, if you recall, some of them has exponent. We raise to the power some of them. If you recall from the previous lessons, in rewriting it, some were being raised to an exponent. So we pick the lowest exponent. For the common factors. Yes, so in expressing or in finding the HCF of given numbers using the prime factor tree, first of all, you express the given number or the given numbers as a product of its prime using a prime factor tree. Then you write down the common prime factors. That means those prime factors that cut across the answers produced from the step 1. And since some of them carry exponents, we pick the lowest exponent for those common factors. To put it in action, let's take a look at this example. Find HCF of 9 and 12. Find the HCF of 9 and 12. Quickly recall, the first step is to express. So solution, express 9 and 12 as a product of its prime. Now let's do that. So in expressing 9, let's pick the first one. 9 as a product of its prime. 9 becomes the head of the tree. We pick, let me list my odd numbers here, my prime numbers here. I pick the least 2 to divide 9, which isn't possible. I pick 3. I pick 3 to divide 9, which is 3. So now 9, I have 3 times 3. Why did we end? We ended because the answer we had on the right is a prime number, so we have to stop. We have to stop. So this can be expressed as 3 raised to the power 2. 3 raised to the power 2. Good. Expressing 12 as a product of its prime, I can use 2 to divide into 6 equal parts. Because this is not a prime number, I have to continue. With my division. I can use this same 2 to divide as 3. But because this is a prime number, we end over here. So now 12 can be written as, I pick my prime numbers, 12 times 3. Sorry, what was I thinking? 12 can be written as 2 times 2 times 3. And that is 2 raised to the power 2, as we can see here, times 3. 2 raised to the power 2 times 3. So we've been able to perform the first step, which is expressing the given numbers as a product of its prime. The second step is to list the common factors. So we can see 3 here and 3 here. Good. So we list 3. We can see 2, but not here. So 2 is not common. 2 isn't common. Now, that's the second step. The third step was to, now you can see for the 3, we have 3 raised to the power 2 from the 9 and just 3, or 3 raised to the power 1. Let me put it that way. So 3 raised to the power 2 and 3 raised to the power 1. We pick the least. Comparing 2 and 1, we pick the least. We pick the least as our answer. So 3 raised to the power 1 or just 3, any of them works. We don't have any other common factors. 2 isn't common, so we leave it. We don't add it to our answer. Now 3 raised to the power 1 is 3. Therefore, the HCF of 3, what was it, of 9 and 12 is 3. You can confirm from the first method of solving. So for 9, we have the factors to be 1, 3, and 9. And for 12, we have the factors to be 1, 2, 3, 4, 6, and 12. Right. Then the common ones are 1, 3, and I believe that is all. And the highest from it is 3. And you can see that confirms our answer. That confirms our answer. So for the method to choose, that is up to you. The method to choose is up to you. The one you are convenient with, you choose that one. Let's look at another example. So find the HCF of find the HCF of find the HCF of 6, 9, and 27. Find the HCF of 6, 9, and 27. Now let me change this 6 to something like 18. Can it be? Okay, 18. So 18, 9, and 27. 18, 9, and 27. You may choose any of the methods, but since I am teaching, or we are going through the prime tree method, we are going to use the prime tree method. So for 18, as a product of its prime, we have 18, 2 into 18, 9. We keep dividing till we reach a prime number. 3 into 9, 3. And that is the end of the tree. So 18 can be expressed as 2 times 3 times 3. And that is 2 times 3 to the power 2. Good. 9, I believe we already saw it in the previous example, is strictly 9 equals 3 times 3, and that is 3 squared. And for 27, we have 3 dividing into 9 and 3 and 3. So 27 is equal to 3 times 3 times 3, and that is 3 raised to the power 3. So that is the first step. The second step is to pick the common factor or the common factors. The common factors we have here, I believe, is 3. 2 appears only one time here, doesn't appear in the rest. So the common one is 3. So the HCF is 3, but we pick the least power. So we have here 3 raised to the power 2, 3 raised to the power 2, 3 raised to the power 3. So we have to pick just one of the least. That is 3 raised to the power 2. And 3 raised to the power 2 is 9. Therefore, the HCF of where our numbers are 18, 9, and 27. So the HCF of these numbers is 9. You can confirm that from the other method of finding HCF. So I'll give you an example to try. You pause the video, then we can take a look at the solution together. Find the HCF of 8, 14, and 20. Find the HCF of 8, 14, and 20. Now the solution. First of all, don't forget we are still using the prime factor tree. First of all, I express my 8 as a product of its prime. So 8 is 2 times 2 times 2. I encourage you to rewatch the video on the prime factor tree if you've forgotten the steps. Or for new viewers, you can visit that lesson on how to express a number as a product of its prime. So for 14, we have 2 and 7. 7 is a prime number, so we don't go further. And for 20, we have 2, 10, 2, 5. So 20 is 2 times 2 times 5. And this can be written as 2 raised to the power 2 times 5. That is the first step in finding the HCF. Now let's list the common. So we have our HCF is equal to, let's pick out the common factors. I believe 2 is here, 2 is here, 2 is here. So we pick 2. And the 2 here can be written as 2 raised to the power 1. Here can also be written as 1 power 1. Yes, so the 2 being the common, the least of the power is what? Of the powers is 1. The least of the powers is 1. So 2 raised to the power 1 is the same as 2. That gives us the highest common factor of 8, 14, and 20. I hope this is clear, and I hope you had it right. If you didn't get it right, do not panic. Go over the video. If you have to revisit the prime factor, the lesson on the prime factor tree, do so and come back to this lesson with full confidence. And this time around, I assure you that you will get it right. With that said, we'll see you in the next lesson, where we'll be talking about the lowest common multiples. Lowest common multiples. See you in the next lesson.